Welcome to the Maritime Vision podcast. I'm your host, Paul Wioli. In each episode, we bring you exclusive interviews with maritime professionals, industry experts, and students. Our guests come from different backgrounds, including shipping, yachting, offshore, supply chain, and more. Our goal is to give you all the knowledge you need to succeed in the maritime industry. Hello everyone, welcome back to a new podcast episode. And today we are with Athanasios. So Athanasios is an offshore structural engineer. So it's quite an uncommon position in the industry, but it's quite crucial. So it's a pleasure to having you, Athanasios. I think today you're going to provide us a lot of insights about your role as an engineer. So firstly, can you introduce yourself, please?
Yeah, sure. Before I start, I would like also to thank you as well for inviting me here. It's a nice opportunity. It's really nice to discuss about our jobs and the things that we love. I'm Athanasios Droutsas and I come from Greece. I was born and raised in Athens. And when I was 18, I decided to go to a different city to study. Still in Greece, but 700 kilometers to the north. And yeah, it was quite some different experience. I studied there civil engineering, but my specialization was again in structural engineering. And maybe in Greece it's still compulsory to join the army. So I joined the army, and then I ended up in the Netherlands doing my master's. So I live in the Netherlands since 2015 in August. It's been almost 8.5 years. It's quite some time now. I'm working as a structural engineer since 2016, basically, when I started with my internships in my previous company. But we're going to get to know all these small details later. So, yeah, normally I'm living in Rotterdam. Nice area, really glad with it. But currently I'm located in Abu Dhabi. So we have a call right now with the Emirates. And yeah, I'm here on assignment for my company where I'm going to stay till July on what we call a rotation. So I'm going to be here 6 weeks, then I'm going to be back for 4 weeks, and then again back in Abu Dhabi for 6 weeks. So this is how it works for now.
Okay, interesting. First of all, why did you choose to work in this offshore industry?
So it comes a little bit from my studies. I studied civil engineering, and then I didn't want to do exactly the same for my master's. I had quite some options back then. And I chose the Offshore and Dredging Engineering Master Program in TU Delft. So my idea back then, it was to basically take a bigger spectrum of knowledge within structural engineering to see what is happening not only on land, but also offshore. And then I got into this, kind of magnificent world of offshore. Yeah, the industry is really different than the one in civil engineering, let's say commercial buildings or bridges, or it's totally different type of engineering. So this is my introduction, let's say, to this world. But I spent 1 year in Delft for my studies, and I finished with the courses. And on my second year, I decided to go with internship and to do my thesis in a company. I did it in Damen Naval.
Yeah.
Don't know if you're familiar.
Yes, sure. It's one of the biggest shipyards in the Netherlands. Yeah.
Correct. It's the biggest one, basically.
Yeah,
and they have different divisions. And I was in Damen Naval in Vlissingen, kind of small city in the south.
I know, yeah.
So yeah, this is how it started. I was doing structural engineering within for let's say the shipbuilding industry. So there we were designing vessels, but it's not that far away from the rest of the offshore world. And then I came in 2022 in my current company, which is called Boskalis. And here we do, it's a very big company, but in a few words, it has 3 divisions: dredging, offshore energy, and salvage and towage. And I'm doing work for offshore energy, which can be from installation of oil platforms till heavy lifting for wind turbines, subsea cables, you name it, basically everything that is related to offshore energy. We are having a division and a team that is doing something about it.
Okay.
My studies were the main reason.
So sorry to interrupt you.
No,
I just wanted you to just make a very short introduction of each segment. You said dredging, offshore energy, and I forgot the third one.
The third one was salvage and towage.
Okay, what else?
I will start with the third one, indeed, because it's the coolest one. Do you remember that a vessel was kind of stuck in the Suez Canal, a container vessel, and
Yeah.
everything was blocked? The company that basically took the vessel out, it is the Smith. It's called Smith,
Okay.
and it's part of Boskalis. So
Okay.
you can see Boskalis as a big umbrella, and salvage is basically the how can we put it? This industry is the industry that goes and saves ships in distress. So it could be a
Okay.
vessel that sank, and then you want to take it out. It could be a vessel that is stuck, for example.
Okay.
Another very famous project that we had last year, it was an FPSO called Safer outside Yemen. And this one was staying in the sea for like 40 years, no maintenance. And there was a big risk that the oil can flow into the sea. That was a huge environmental risk. So these guys went on the vessel, on the FPSO, took with pumps all the oil outside, and then they towed it in safe harbor, basically in safe waters. So they are doing very big projects. Not everything goes into the light of publicity because some of them are kind of confidential. But this is what they do. They basically save the day in cases
Interesting.
that
Okay. So this
vessels
is
or
salvage.
could be offshore structures that collapse or everything. And they go and they take them out. And
Okay.
towards is like attack,
Yeah.
taking something out, pushing something or pulling. And then we have the dredging. Dredging, which is the traditional, the core of Boskalis, is about taking basically a little bit of sand and then making an artificial island. So
Yeah.
you take the sand and you put it there. That's the idea. But it's not that simple because you can go also, for example, in a port and make it deeper. So you can have bigger vessels that can berth. Or, for example, you can go to a canal and then make it wider so larger vessels can pass through. Generally, they are doing a lot of land-related work. So they take some soil from one place and they put it somewhere else. To put it very simply, it could be sand. It could be. They do also a lot of infrastructure work on land, not only offshore. So it's a very big division. So for us, you can think of it like 45-50% of the revenue comes from there, and the other 45-50% comes from the offshore energy, and some small amounts come from salvage and towage.
Okay.
Because the interesting part, and I left it for the last, is the offshore energy. We have 7 business units within there. Heavy marine transportation is one, the one that I'm working mostly, where you transport something very heavy. Then you have offshore heavy lifting, subsea cables, marine services, as we call it, survey. What else we have? Subsea services as well, and seabed intervention.
Okay.
So we can go in depth for them, but if you have any questions, let me know.
Okay. So it's a very interesting. Thank you to provide us this quite insight about those three. So of course we will be more focused today about offshore energy because this is where you are working. First of all, can you tell us a little bit what is a offshore structural engineer?
Yeah. Let's start it with. I can imagine that not everyone is fully into engineering. Yeah. So let's get a little bit on a higher level. Let's assume that you want to transport a platform that weighs like 20,000 tons.
Yeah.
Somebody has to calculate if the vessel on top of which you put the platform is going to break in two.
Okay.
Somebody has to calculate how you are going to keep the cargo in place when you are in transit. So if you have a little bit of high seas, let's say, and then the vessel starts moving, you don't want your cargo to fall overboard.
No.
So somebody has to calculate the structure that is going to keep it in place. So what we do in general, structural engineers, for these operations, we try to ensure that all the structure stays in place and it can withstand all the operational loads. So that is the core of it.
Okay, interesting. So I imagine, how are you working with this? I mean, for example, you have a mission, I can say offshore, you need to bring some windmill into the sea, and you need to calculate how many windmill you can put into the ships, about the resistance, everything. Is that correct?
Yeah, we are collaborating also with the people that are calculating how many you can fit in, because for this one goes mostly with our draftsmen within our company. But what we do as structurals, when you take a big monopile, which is the foundation for a windmill, for example, and then you put it on your vessel, you cannot just place it on the vessel or your main deck. We create some structures which are called grillages. So you place it there, something to keep it in place.
Yeah.
So this, let's say, semicircle that where the monopile is on top of it, it has, it's a big structure. It has thick plates, and we have to calculate if it's, let's say, 30 millimeter plate, 20 millimeter plate, 50 millimeter plate. We have to see if this construction is gonna buckle, because when you put a lot of compression, it can buckle, for example, even if that's not the case for grillages, but I'm just for the sake of the argument what we calculate. Then you have to see also if your vessel can withstand the loads, because you can make something very strong above your deck, but if your vessel is not strong enough, it's gonna go through your deck, let's say, or you're gonna see very big deformations. So this is what we calculate. Think of it mostly in terms of forces and resistance. Another simple way to think of it is like you have a civil engineer for the buildings, and they calculate the thickness of your plates, the width of your columns, the size of your columns, the size of your beams. This is what we do as well, but the construction for the structures that are related to our operations. We calculate how thick they're going to be, how strong they're going to be.
Okay, so I mean, it depends the mission. So depending what kind of mission Boskalis, for example, will do, they call you and they say, okay, now we need to work on this specification. It will be this vessel, and you need to start making the calculation. I imagine.
Yeah, you're very close to it. The issue is that we have a very broad range of different operations. So let's assume that somebody comes from the sales department and they say, okay, we have to transport, as you said, monopiles, for example. Let's start with that. Then we figure out which vessel we're going to use, because you need different types of logistics to see, which vessel goes here and there. It's like chess, and you have your pawns and then you place them according to the schedule. We have people that are actually doing this job, figuring out how the vessels are moving and, which vessel is busy with what. And then they come to us, and our first step is to see, as you said, the mission. So what is the project, what we want to achieve, the scope of our works. And then we say, okay, this is what we want to achieve. Then we start with the creative part of our work, because our work has many different parts. And the creative part is that you start imagining a structure, how I'm going to do it. Because there are, let's say, so many solutions that you cannot name, let's say. If you ask 10 different engineers, you're going to take 10 different answers. And of course, we don't reinvent the wheel. We have previous projects we can be based upon. But still, there's a lot of room of improvisation, because every project is slightly different. What we say here often is same, but different. Because they come to you and they say, this is same, but ends up being significantly different. So this is how it goes. Somebody comes and then we start thinking in a team or on your own. Then you make a concept design, and then you start with your calculations on a later stage.
Okay, so I imagine it's a custom creation. I mean, every time it's different. You cannot use the same. You told us about the specific name of it, this part, custom part.
Grillet, the grillet.
Grillet, exactly. Yeah. So it's custom every time.
Absolutely.
Yeah.
And that is what is interesting, because, for example, you can imagine that if you want to put a monopile is a big cylinder that you put on your seabed. You take a hammer, you hammer it down, and on top of it, you place your tower for your wind turbine. Okay, you place first the TP, transition piece, then your tower, and then on top you have the nacelle with your wind turbine and the blades. So the monopile is a very big thing. We are talking about, could be 2,000 tons. 3,000 tons, just to give you an idea. We're talking about really, really big amounts. Now, if another project comes and then you still have to transport monopile, but they have different diameter, you need new grillages. But then you could claim, okay, they are the same diameter, but they're longer, so they are heavier. So you have to make stronger grillages than the previous project. And there could be so many different things. It even depends on the vessel that you put, because different vessels have different behavior in the sea. And if you have high accelerations on the vessel while it's moving, this is something that we have to take into account, of course.
Okay.
Because it's different to put a monopile in onshore where everything is steady, and different to take it to the sea where things are moving. So
Okay.
there are so many parameters that you have to take. So we end up basically, to give you the final answer, we end up basically 99% to that we make it custom made for the project.
Okay. Very interesting.
Yeah.
And sometimes can you reuse?
Yeah, here and there sometimes, but not that often.
Okay. Quite interesting, by the way.
Yeah.
I want to ask you something more about to go more technical, so I take
Okay,
risk
sure.
now. About the calculation on all the physics, because you need to know the resistance of materials. In English, it works. What kind of calculation you need to make? What it is this very technical, I can say, geeky part of your job?
Yeah, we can go definitely for that. We can talk hours for that. We really
Yeah, I
like
know.
them. So yeah. So what we do, let's think of it. Okay, let's think a very simple example. If you have just a rod, a circular profile, it's just
Yeah.
a simple rod. If you grab it and you start pulling it, then you can say that the stress, as we call it inside this rod, is equal to the force that you put divided by the area.
Mm.
So we calculate this value and then we compare it with how much this rod can withstand.
Okay.
So normally we have something which is called the yield. So that is the part that your structure is not behaving linearly anymore. We're going to the non-linear part, but that's we have to get into real technical parts. And then we say, okay, it goes to yield approximately at this value. Then the yield is given as a stress. Then we make it as a force. And then we say, okay, it can withstand 200 kilonewtons, which is a measurement of force based on its diameter. Then we say, okay, we are going to apply 100. So we have also certain safety. This is what we call the allowables, because you don't want to go up to the exact limit of your
Sure.
strength. We want a little bit of safety. I mean, for us, one of the problems that we have is one mistake too much. So
Yeah,
we have
large.
many safety factors, let's say, in between. We have safety factors on the loads. We have safety factors on the material, on the strength of the material. We have safety factors also on the on top of these two. We make it even stronger. So this is a very, very simple example that I was giving when you have some structure in tension. But yeah, if you have things in compression, they don't behave exactly the same way. Because as you know, if you take the same rod, instead of pulling it, you start pushing it, depending on its diameter and its length, that's the basic, and at the end constraints, then it can buckle.
Yeah.
And if it buckles, then what we say, it loses its stiffness. So it stops doing its job.
Okay.
So you could start seeing very high deformations. You can end up even in collapse.
Okay.
So we check also for buckling our structures. Then we want to check also the welding of the structure, because you weld individual items with each other, and then you weld stuff on your main deck. You have to be sure that these are strong enough. Otherwise, you have a big load and you see the whole structure being detached from your deck and then fly away.
Oh, yeah.
Yeah. Then we have to calculate stuff sometimes, not that often, against fatigue.
Yeah, fatigue.
Fatigue is a big issue of the steel structures, and it's a very complicated one regarding the academics behind, let's say, the formulas. And that's why a lot of research is still being done for fatigue. And these are the big parts that we are doing. Mostly we do strength calculations, that the stresses inside the bodies are lower than what we assume as safe stresses. About a certain safety threshold that we have. We calculate deformations, so we don't want things to deform a lot, because even if the stresses are not big, if the deformations are really big, you can have operational issues. So you can have deformations and then something doesn't fit anymore in between. So you have a profile which is like a U, you want to put something inside, but then with the deformation it closes, it cannot fit.
Yeah.
Stress-wise it's okay, but yeah, you have to think about it.
Interesting.
And then we calculate buckling, welding, fatigue, and then you could have also more elaborate analysis, like non-linear analysis, where things are becoming more difficult in terms of the formulas and the equations behind and the understanding of the physics.
Okay, very interesting. To come back with fatigue, for example, because I know the many accidents we have in this industry is due to fatigue. For example, this submarine like Titan, it was, I think it was due to fatigue. We have a lot of tankers who break into pieces because of it as well. You said it's quite complicated to anticipate it. Yeah, you can elaborate on it.
Oh yeah, I can elaborate a bit more. So different materials behave differently. So, for example, fatigue on steel is totally different than fatigue on composites, which, for example, for composites, even more, let's say, of a black box. Yeah. Still, we have an idea, but we don't know exactly what is happening. So, for our listeners, what is fatigue? The easiest way to think about it is to take one paperclip. You raise the paperclip, and then you push it in one side. That puts some stress in the paperclip.
Yeah.
But it doesn't break. But if you do it 500 times, it breaks.
Yeah.
Basically less than 500, but you get my argument. If you do it many times. So this process is called fatigue, and then it starts basically with a micro crack on the surface, and then it propagates through the thickness of your element.
Okay.
So this is what happens for fatigue. The problem with this is not that you cannot predict it exactly. It's that they have so many important parameters which are difficult at the design phase to exactly calculate them.
Okay.
So what we do, for example, my previous job it was on military vessels. So we're building mostly dummy naval, it was naval vessels. And these vessels are also prone to fatigue because they have to be light in order to go fast. And they don't have the option of avoiding bad weather, because if you have to go now, you go now, whatever weather you have in between. So they are exposed to high stresses, which makes the fatigue even worse. So they are really prone to fatigue, and then you have to calculate them properly and be sure about it. So you have to know basically to make a good assumption about where your vessel is going to sail for a long time. Because you have to know, you're not going to sail every day at 8 meters significant wave height. Let's say, I start also a very big value. Let's say 5 meters significant wave height every day for the next 20 to 25 years. It's something in between. A little bit you're going to be at shelter waters, and a little bit you're going to be at port. You have to calculate that and make a good assumption. Then you have to know very good what that means for your vessel, how much stresses you are going to have. And on top of that, you have to know very good how your connections are made, because fatigue is really prone to the local detail. It's a local phenomenon. It's not a global phenomenon. Yeah. It can start as a local and then propagate and then look as global, but it's not global. It starts locally. And the local part is very much dependent from, let's say, even on the welder's ability to weld properly. Okay. Even how you treat your weld after welding. There are post-welding treatments that you could do to improve the fatigue life, basically. So there are many things that you could do. It's just that it's, let's say, a multi-factor problem. It takes so many things into account. And that's why we have structural engineers which are basically fully specialized on fatigue. And they do that because it's so different that even if you can have a structural engineer and do totally different things.
Okay, interesting.
Yeah.
We will come back about collaboration between. But I know it's a lot of things now about the corrosion. Corrosion is part of fatigue as well.
Not exactly. There are two different phenomena.
Okay.
So both create problems to your structure. Yes. And for example, corrosion with fatigue on steel it's a very good topic for research. So if you have students within your team, it's a very hot topic. It's the interaction is kind of nasty because you get between chemical engineering, because it has to do with chemistry, the fact that we have corrosion. On top of that, you have also the fatigue, which is a mechanical problem, it's a structural problem.
Okay. Very interesting.
And keep in mind that we design our vessels and our construction, let's say offshore, also for fatigue also for corrosion when we have them permanent structures. You remember earlier we're discussing about grillages. We're going to use it only once. We don't take any corrosion into account. But if we put a structure which is going to stay permanently, based on what it has around it, if you have salt water, you're going to take bigger corrosion addition margin. So if I make a calculation that I say I need 10 millimeters of a plate, but I have sea water from one side, I'm going to put at the end 11, 12 millimeters. So even if I lose one or two from corrosion in the next 25 years, basically you lose around 1 millimeter for 25 years, just to give you an idea, only from one side, then I will make it 11, so even if I lose one, I'm still strong enough.
Okay, taking marge. Okay.
Yeah, taking an extra margin.
Okay, and then what about the temperature? This is something you cannot predict.
Yeah, you could. Okay, that was part. We still indeed can start elongate and contract with it, and it could have some operational effects. I cannot share so much because, as you can imagine, the things that we were doing in the previous job was a little bit more, not everything can be shared so publicly. But the idea is, let's put it like this. That's the best way to put it. I'm working till 2016, as a structural. I've never taken thermal stresses into account to one of my calculations. I had them in my university years. I'm still studying, by the way, quite some time. So I'm still doing, I had them recently again, what it means to have thermal stresses in your structure, but we don't use it. It has to be very specific application within the offshore industry to take into account.
Okay.
It could be, but I haven't seen it.
Okay, well, it's good to mention it actually.
Yeah.
So you worked on different kind of materials like steel. Is it the most common one? I imagine this is steel.
Yeah, 99% within our industry, especially the offshore energy, is steel.
Okay.
Now, you could have aluminum when you want to reduce your weight, because aluminum has basically, that's the big advantage. And for my thesis, I worked also with composite materials, which is also totally different. It's different philosophy, totally. But steel and aluminum, at least as a philosophy, they are the same. They have definitely different material properties, but you have many commonalities in terms of the behavior. And yeah, steel is the 95%, let's say, and then a little bit of aluminum, sometimes composites, but that's very, very rare.
Okay, quite interesting. And now I want to ask you more about it, because I imagine, because to know all this resistance of materials, you need some data, you need to use some software. Can you elaborate about it?
Oh, yeah, absolutely. Now, the good thing with the material data for steel is that it doesn't require so much input.
Okay.
It's kind of, how can I say, weird, let's say, can be surprised, but basically the only thing that you need is a Young modulus, a Poisson ratio, and then you need the material yield, which depends on the grade of your steel.
Okay.
So you get it, let's say, more or less from your supplier. These are the things that we mostly care, especially for our linear analysis. When you don't run non-linear, these are the things that we 99% use. So these are readily available and you don't have to do so much research about it. But indeed, we use a lot of programs, but we use the programs to analyze our structure. So when we started, we said that we basically, as structural engineers, we want to see if a structure can withstand certain loads. So what do? We take some software programs like ANSYS, which is very famous, FEMAP, Nastran, SACS. These are the big ones that are within the industry. And what you do there, you see your structure, you make an idealized model. So you find your vessel and it has a main deck. Then you put a plate there. And below that there is a beam, a stiffener as we call it. Then you model it as a beam element or as a plate element, depends on what you want to achieve. So basically we make an idealized model of our structure within the program. We put the forces that we have, and then we click a button to analyze the structure. Okay. This is what we do when we say we run FEM analysis, finite element model analysis.
Okay.
So we make an idealized model of your structure. But for our jobs, we use a lot of hand calculations as well. So you could see within this software that we can have some Excel files, which are, for the quick and dirty calculations. And all this, the more quick and dirty that you go, the more conservative you become. So it is safe. At the same time, it could be that sometimes you can over-design a few things here and there, but at least within offshore energy, the governing parameter is not the weight of the material.
Okay.
So you don't mind if you put a little bit more and do it in a fast, but always safe way. Always safe. You don't take any discounts there.
Okay. Quite interesting. Yeah. I think that's very important because you spend all your days in front of your computer working on this software. So I thought it was important to mention it. Okay, so I think in terms of technicality, we are quite good now.
Yeah. I mean, it can get really, really technical, but I can imagine that within a podcast, it's really difficult to go so much in depth.
Pictures, shame, etc. So that's
some pictures. Yeah. So that's why we don't want to go, for example, about normal stresses, bending stresses, von Mises stresses, and the differences between them, how the shear stress affect all this. There are so many in between the tiny letters, and
sure.
It depends also on the person. For me, I was always wanting to have an academic background behind. That's why I'm still studying. I feel that there is just studying is not enough. After one point, you have to keep up with the knowledge, either not to forget it or to learn new things. And you can get really, really technical with these parts. But the idea here is to have also a fun discussion and not make people scared about what we're doing.
Yeah. No, of course, at least we give an overview of what is it your job, because I think it's quite unique what you say. I don't think I can find this information easily on YouTube or other. So again, thank you for that. Now we are going to talk more about the skills and qualities, abilities you need for people who want to be like you, a structural engineer.
Yeah, sure. So let me understand the question correctly. Do you mean what kind of skills you need to be a structural engineer? Okay, you need in order to be a structural engineer. The first and foremost that comes to my mind is analytical. So you have to be able to understand the structure, to visualize the problem, to have the gut feeling of how it's going to behave, and then be able to put this into numbers. You can have all sorts of discussions about how things are going to behave and what is good, and then how the high level qualitative part. But at the end of the day, always you need some numbers behind to back up your claim. So a lot of times it's better to do a high level analysis where you say this is the strength of this structure against this and this type of loading, rather than to say, okay, this is strong enough qualitatively. You always need the analytical part. Another part that you need mostly on the soft skills is the communication. It's absolutely necessary within our job function, even if that comes also as a surprise as well, that you have to be able to communicate with people properly, clearly, and on time. And why I'm saying that, normally discipline engineers, we are living in our small world. You are on the side corner, your small office, and then you do your calculations, you give them, and this is what most people think, even within the industry. But if you think about it, everything that you touch in the operations, everything that you want to change, to move something or to change something, it has some effect on the construction. So you have to be able to communicate what it means when people are making this kind of changes, to communicate how much time it's going to take for you, to find the correct balance between quality and speed, because as we were saying, the quick and dirty, you can do it to finish fast, but you go a little bit more conservative. But you don't want always quick and dirty. Sometimes you want to optimize your structure. So you spend a lot of time making design iterations and then figuring out exactly what is happening. All these, except from the academic level, require also the communication. So except from the good academic level, require communication. So if I had somebody in my team who is very good academically but cannot communicate, I'm not sure that I would choose him from somebody who knows, of course, the basics and he's not dangerous, let's say, to make big commissions, but can properly communicate. It's that significant for our job because you have always to very clearly state what is your assumptions, what you calculated for, what is going to be used for. And that is, so you have to have also some social skills on that perspective. And I could say also being able to handle stress as well. There's a big responsibility with that comes with the job. You cannot have collapses, you cannot have big failures, because best case scenario, that means a huge loss for the company. Worst case scenario, we're talking about human lives. So it comes with a certain stress from the responsibility. But these are on the negative part, let's say. There are a lot of things on the positive part as well within the job. So one of the, it's not exactly skills, but it's a way of thinking. I have seen many structural engineers who are not so eager, let's say, so enthusiastic about their jobs. And most of the cases, what they had as a common denominator, it was the lack of fulfillment when you see your structure being built, when you see it in operation. So something that I would highly suggest to have if you want to become a structural engineer is to feel, let's say, pride, to feel fulfillment, not pride.
It's a good one,
Pride is not a good question, it's a good word. Fulfillment when you see your structure, because this is literally the driving parameter behind our work.
That's a good one. I can imagine when you spend so many time to build this project, and you can see in real life, that's my work. I think the fulfillment is quite important.
And we are talking about huge structures as well. Just to give you an idea, last year we transported a structure. It was like 30,000 tons. It's like 3 times the Eiffel Tower in terms of weight. Can you imagine? So it's 3 times. So we're talking about very, very high loads.
We are talking about taking the science and make it the max limit, using the limits of the physics. That's why it's getting impressive.
Generally we're pushing always in the safe way. But we are generally pushing every time that we try to push, and then we do it step by step within this industry. But right now you have humongous structures. You have crazy big structures for now.
I've seen that, especially in the Netherlands. I've seen this heavy lift vessel. It's quite impressive to see, first of all.
Our heavy lift vessels, for example, can lift up to 4,000 tons and 3,000 tons, the two big ones that we have. So we're talking about
and most of them are semi-submersible, so it's quite impressive when you see them under.
Basically the semi-submersible is slightly different. These are the HTVs, the heavy transport vehicles that you are mentioning. So these are the semi-submersible, but you are semi-correct, because one of the two vessels used to be an HTV, an HTV heavy transport vessel, which was semi-submersible, and we converted it to offshore heavy lifting vessel, which was basically Boskalis 1. That's the name of the vessel. We have many conversions also on the heavy lift vessels.
Quite interesting. It's plainly an offshore fleet. You have different type of vessel. It's not like dry bulk. You have the Panamax, you have the capsize. We don't have so many names, and it's not classified so specifically, so that's why.
And I can imagine, especially for your world on shipping, you need to have all these classifications because, it plays a big role for us. They are so special as a structure. For example, in Europe, they're discussing about making so many offshore wind farms. But one of the biggest problems that we have is that we don't have enough vessels to install them. So even if you find the money, even if you find the yards that can produce all these structures, maybe you don't have enough vessels to put them. So it's still a small market, and it's not that easy to get in as well. So
interesting. But first of all, and secondly, your industry is quite customs. I mean, it's not like the shipping with like liner shipping. It's always the same. You built everything regarding the project itself, so that's why. Interesting. Let's talk about the collaboration, because you cannot work alone, I imagine. You need to collaborate with your colleague. What kind of position they have? Can you elaborate, please, on it?
Oh, sure, definitely. Indeed, this kind of projects required between tens and you can go up to hundreds of people to, to implement this kind of operations. So I will stay a little bit at my world, the world of heavy marine transportation, because this is mostly the project I'm doing, where we are a little bit less, let's say a few dozens, let's say, of people. So you have to see the project from the start when it's still at the sales. We have a tender phase. We still a little bit of engineering, like a concept engineering, is being done at that phase, and then later we get a contract. So let's say on your everyday life, you have different discipline engineers who are doing their individual tasks, and they're being coordinated by a project engineer. So the project engineer, you could think as the person that runs the project. He has an idea. He comes into communication all the time with the client. He has an idea about which documents have to be delivered and a good idea about all the disciplines. So he knows that in order to have this operation, we need to do this and this and this analysis. And he gives it to us.
Okay.
And they say, for example, from structural engineers, I want somebody to calculate this structure and I want it ready by this date. He does the same with the marine engineers. He does the same with the draftsmen. He does the same with the transportation engineers. So he gathers all the data. He gathers the reports. We have a big reviewing process as well. So he reviews our work, and within the same disciplinary, we review each other's work. So if I produce something, somebody else is going to review it. If somebody else produces something, I'm reviewing it. In order to be sure that we have a certain quality. So for us, within the discipline engineer, we mostly communicate with the project engineer, and this is our voice to the outside world, let's say. But we have regular meetings where we sit down all together, weekly by weekly, depending on the project. If it's really busy, we have it every week. If it's not that busy in this period, we have it every 2 weeks, where we sit all together, all the teams, and we discuss about the process of the project. So we say we have this issue there, and how we're going to solve it. So I get to know the whole team on what are they working on, and if I have any questions, I can ask them directly. So this is how it goes. Every 2 weeks we have progress meetings. The project engineer organizes all of us, and then he communicates that with the outside world, mostly with the client. Could be also marine warrant surveyors, could be classification societies, could be anything. On top of that, we have also a project manager who is getting the whole project on a higher level. See contracts, see big decisions about changing vessel, changing ports, changing whatever you want to change. We have also our safety guys. So as we call it, health safety. It's CQ, we call it. So safety, health, environment, and quality. And and they communicate. And they are also involved, so we know that we do it always in a safe way.
Okay. You don't have DPA for safety as well? No? It's
DPA, I'm not familiar with what DPA is.
I think it's in offshore, but more in platforms, petrol platforms. It's taking care of the security of the employees by taking measures.
Maybe it's a specific role that we don't know. We have somebody regarding safety, but within our company we call them CQ. Sometimes they call them AGC as well.
Okay.
But to be honest, DPA I haven't heard of it.
Okay, but I mean, it's just in class we had a project on. We talked about it, so that's why. Nice. Okay, so it's a big collaboration. I mean, a project. It's all about working together anyway. I want to ask you other questions. Do you have some anecdotes to share in your career?
Yeah. I mean, there are quite some about what happens, let's say, behind the scenes.
Yeah.
Okay. But again, always as a structural engineer. So, yeah, there are many things. Now, a lot of different scenarios come to my mind. The first one that comes, it was also last year in March. I got the opportunity to go to Taiwan and work offshore. So, and work on the vessel during the installation of the foundations for wind turbines. And I went also to ICE. So there, this is something like an anecdote you don't expect so easily from structural engineers, but it could be a nice opportunity that you get. So you could keep it in mind that we can give, let's say, within structural engineering, this kind of opportunities as well. Then another anecdote behind the scenes now is that there is a crazy lack of engineers within the Netherlands. There is a lot of companies are looking for. We are looking also for structural engineers as well, even for junior structural engineers. And there is a big lack of engineers within the industry in general and in the Netherlands. So this is something that is good for your audience to know.
Yeah.
And yeah, if somebody has any questions regarding Boskalis, feel free to share my mail with them if they contact you, because it could be a nice opportunity.
Okay, interesting.
And definitely, I'm happy with my current position. Then another anecdote from inside is, yeah, I have a few from the previous work, which is a little bit more, more on the kind of more elaborate analysis that you could do. But generally, what we have to keep in mind is it is a complicated work. It requires quite some academic background and technical knowledge. But at the same time, it's okay if you have the imposter syndrome. It's something that all the discipline engineers have, also structural engineers. So for your junior, let's say, audience, which are juniors in their work, it's totally fine if you feel that you don't know something or that what is going on around you. At the end of the day, all the companies have processes where a minimum safety is for sure ensured. So that is good. And another one is about, another anecdote is try to be up to date and be able to communicate with all your colleagues. And that is something significant that you should keep up. But generally, within discipline engineering, so when you do something very specific, you don't get, let's say, the spicy stuff, the juicy stuff. This happens on a different level. For us, we are, let's say, the front that we're pushing the actual work forward, and all the negotiations and the agreements happen on a level that on purpose, or sometimes we only get to know them from coffee discussions. But it's difficult to share, especially publicly.
Yeah, sure, for sure. Yeah, no worries. Yeah, I think what you say is quite interesting on especially to come back what you say about the lack of structural engineer, engineer generally in the maritime industry, and especially offshore. I think it's because, as you mentioned at the beginning, it's quite hard to find any contents or some about it. Even for myself, I try to know more about offshore, but there is no information about it.
Yeah, indeed, and there are so many also companies out there. In the Netherlands only, let's leave Boskalis and Damen on the side for now, but you have also Deme, which are one of our competitors. You have Van Noord, of course. You have Blue Water, you have Hausmans, you have fully engineering companies like TWD and VAUC. You have Mammoth and Jumbo. There's all C's, of course, Herema. It's like, probably I forget also other big ones as well. But yeah, you can even choose what it fits you the best. For example, we have mostly operated, let's say, concentrated towards operations like Boskalis. We have fully engineering companies who just do calculations. So sometimes we outsource work to them, like the WD and VAUC or Navisbu, for example. You have companies which are, having engineers and you just rent them out, so you get different experience from different companies. It can happen, you can have anything. Yeah, there are so many jobs around there that can fit also to your specific needs and the prospects that you have. So yeah.
Okay. Yeah, thank you for to share this information. I think this is I don't have more questions to ask you because you answer to everything. But if you want to add something, you can do it.
No, it's not that I have something specific to add. I just want to have your opinion, let's say, about your experience up to now with the podcast, with your guests, with the expectations, because I was checking your channel and I was happy to see the progress and all the people that you have.
Yeah, thank you.
But I didn't see talking so much about your podcast and the thing that you're doing, how you started about it.
Yeah, it's a great question.
Yeah.
You are the first guest to ask this question.
Okay.
Yeah, I mean, no, it's quite interesting. I mean, when I started, it was in like 1 year ago. Of course, my goal it was to give this visibility to the industry. You know, the maritime industry, we have so many different jobs, so many different roles. And I mean, it's englobe everything: commercial, technical, career at sea, everything. So I was so passionate about it, but I wanted to, you know, to make something with it, to share it. And the podcast was the best way to do it. I mean, to talk with people working in this field. And what I like about the podcast is the diversity of profile I have. And I mean, everyone can identify to something in my podcast, you know. So that's the thing. So at the beginning, it was not easy because, you know, when you start something, it's always not not doing in a good way. I mean, in terms of setup, how to podcast in a good way, asking the good questions. But then I gained some experience. So I'm still junior in podcasting, only 1 year. But yeah, I think my goal is even if I get a job after, because this is my goal after to work in the maritime industry, I want to maybe to slow down a little bit, but continue with this podcast stuff, making interviews with people. So yes.
Yeah, and that's definitely a good idea. I mean, keep in mind that when you start looking for jobs, to use that and then say that you're doing the podcast, not only for your network and the broader experience that you get from talking with people within certain industries, let's say talking with experts, but also because it shows some proactiveness. You know, that you like this one and then you're proactive and then you're doing it. It's kind of cool. And
it is.
Definitely thumbs up for the the initiative.
Thank you,
and it's very good.
Thanks.
I hope that you still enjoy it because it takes time also, I can imagine.
Wow. Sometimes I don't know, I manage everything with school work and stuff, but I can do it, so yeah. Nice.
Cool.
So thank you, Athanasios. Thank you a lot.
You too.
The audience has any questions, they can directly contact you on LinkedIn, I imagine?
Correct.
Yeah.
And the best one I think is LinkedIn.
Yeah, perfect. So, and especially the students in TU Delft. Because
I studied in Delft as well, so I know quite a few things from there. And at the same time, if they have questions even for Boskalis, because we have many open positions, they can go through me and then I can explain how we work, what we do. Or generally other questions within the industry, for my shipbuilding background, whatever they want. So feel free to share my details.
Great. Thank you, Athanasios, and have a very nice day.
Thank you very much as well. Enjoy your day as well.
Bye-bye.
Bye-bye.
Take care. Thank you for listening and watching this episode. We are looking forward to bring you more insights from maritime professionals, experts, and students. Do not hesitate to follow the podcast on Apple Podcasts, Spotify, and YouTube. Your support means a lot to us and helps us to bring you more content.